Hi, we're Team 10. We are the battery developer simulators, and we work for Omron. I'm Jason. I'm part of the front end team.
My name is Johan, and I'm part of the backend team.
My name is Nick. I'm part of the backend team.
So our project background is based off of Omron. Omron is a company that makes a variety of electronic goods. And so our team is actually from the robotics department. Omron creates these robots called AMRs, autonomous mobile robots, that autonomously move items in a factory setting. So think of like Amazon warehouses, how they have robots move items. Omron has a robot that does things that are very similar. So Omron uses these robots to navigate in a very dynamic environment, and the robots carry two of the main series, the LD series and the HD series. The LD series, of course, contain multiple different types, so like the LD 60, 90, etc.
So the current problem is that we got to develop or determine the runtime of a robot depending on the expected usage or the environment that's going to be in there. And there is a current implementation of it, but it is limited to one robot, which is the HC 1500, and it only predicts the runtime, and it is difficult to understand and use. So our objective is to develop a software tool which can model a Omron arm in a variety of industrial use case scenarios to determine the runtime, current usage over time for the day, the capacity consumption over time for the day. And as a plus, we would need to write a script to summarize the data from each robot's log. And the main deliverables that we have is we're able to actually predict the runtime within the 90% or greater accuracy. We're able to predict the current usage over time from the given stops, wait time at each stop, distance between stops. And as you can see in the graph, that's the solid black line is the prediction from our model compared to like a real data. And we're also able to predict the consumption for completing all the stops, the consumption of current. And we also wrote the scripts to summarize the data for each robot's log. And currently it works with the LD series. So with the summarized data, we're able to train a new model and to use that model to predict the current usage. The current implementation is we run the forest regressor to predict the current usage. And we also have two scripts, one to find the optimal parameters and another one to retrain the random forest with those optimal parameters and compare it to the linear regression model to see the difference in the square error. And it stores all this analysis and the model is being stored in the folder to be used for our backend. Some of the missing features is the capacity of current consumption over time. We only display the total consumption in one single digit. And our current software does not support the HC 1500.
So we created a demo video to kind of show how our software works. It has two main interactive components. One is the front end site, and the other is our API endpoints that allow users to use automation to input the same data. So here's a video summarizing how this works. Okay, that's the end of the demonstration.
So for technical challenges, first had a limited set of data to work with. There was a little more than 100 logs for each of the LD series types of robots. Each log was about only a minute long. So we were able to extrapolate it to basically predictions over a long period of time. Now for the HD series logs, the logs were given in a different format than the LD series. So we didn't have the same values on them, such as current, as we did with LD. So, and also for these, they were for the full battery life versus the LD's single minute long cycles. So, and for what we were given, the previous approach, we were not well documented, so we had to rework for their previous approach and modified it as we worked through it to better work with the limited data we were given. So for the practice control, so one thing we would recommend for teams that approach this problem in the future is make sure you have a good knowledge of linear regression and perhaps machine learning if you want to take the next step. So what we worked well for us is we had a good technical approach and we were able to plan and design it and develop testing. We were able to do pretty well. We had good communication for working, meeting together and making sure we discussed the changes to the code. And we also had a weekly meeting with our mentor in which we were able to update him with our progress. And so one thing that didn't work well was we weren't able to properly divide the work between us more evenly to speed up our progression. And we also had a bit problems with finding the right tools for what we needed to do. So that did delay us in implementing some stuff we wanted.
So for future iterations, I think that there's some changes that we could make to make this better. One is that we would actually improve on the HD 1500's current approach, being that it's missing at this moment. Also, we would implement 5 more iterations in our neural network approach for better estimations. So in conclusion, we think that our solution is quite accurate and provides very powerful visual representations for the battery estimations. It certainly is a lot easier and a lot more concise than reading through the previous Omron CSV logs. However, we think that our project still has plenty of room to branch out and can fulfill even more roles. And our project serves as a great proof of concept that this approach could be reasonably used to calculate the battery logs and serve as an effective solution to Omron's problems. In the future, we plan to create an easier web app and allow for more expandability and higher reliable results through more AI training. Thank you so much.